Good morning. Good morning. Today we'll see about a question or questions together that's combined to calculate the energy required for an object to change from one state to another. Now, we have seen in the previous video specific capacity and specific latent heat. This question actually involves a few sections or segments, so that if you have gotten clear understanding of calculations or the theory of specific capacity and latent heat, you'll be able to solve it without any difficulty, right? I'll give you the question. What you could do is, there I have written the standard values here. Just pause it, try to solve it on your own, and then at the end you can compare your answers with what I have got. I hope you'll get the answers correct. Now the question goes like this: what is the energy required, or what is the total energy required for ice cubes or ice at minus 20 degrees Celsius, so there are some 5 kg of ice cubes. So you want to find out the total heat energy required to change this 5 kg of ice cubes completely to vapor or to steam. That's a question. The question is very simple. You just have got 5 kg of ice cubes. You want to convert all of it to steam or to the gaseous state, and you are asked to find out the energy required. Now this is a very simple question, but then if you have, as I said earlier, if you know how to go about it without any mistakes, then you will arrive at the correct answer. Now the given values or the standard values are here, which is C of ice, which is specific heat of ice, is 2100 joule per kilogram Kelvin or degree Celsius. C of water is 4200. L of fusion of ice, which is like fusion from ice to water, is 3.4 to 10 to the power of 5, and L of vapor, that is from liquid to gas, is also given to you. Now, as I said, those of you who are confident, you can pause this video and go ahead calculating, and then finally you can compare your answers. The others who are watching, now you have to first understand what are the different stages of these calculations, how it proceeds. Now for first, I said it is at minus 20 degrees Celsius, right? The initial temperature of the ice cubes is minus 20 degrees Celsius. Now when will it start to change state? It has to reach to 0 degrees Celsius, because that's a melting point of ice, right? So minus 20 to 0 degrees Celsius it has to reach. Now what would the state of the object be here? Is there any change in state? No, it's only ice cubes getting converted or getting heated up to 0 degrees Celsius. Am I right? That's one stage. So the energy required there, you have to think about, there is an increase in temperature of ice from minus 20 to 0 degrees Celsius, right? Now after reaching 0 degrees Celsius, what will happen to the ice cubes if you still supply heat? The ice will change to liquid. Now when it changes to liquid or water, there will not be any change in temperature. So there is a change in state involved there. So this will be your change in state from ice to water, right? After all of it had been converted to water, what should happen? You have to increase, because you want to convert it to steam. So now it has converted to liquid state. So the liquid from 0 degrees Celsius has to reach the boiling point, right? So there is an increase in temperature there. So you have to increase the water's temperature from 0 to 100 degrees Celsius, correct? After reaching there, 100 degrees Celsius, what will happen? Will it get converted? No, still you have to supply heat energy. For how long? Until all of it is converted. So your E4 calculation will be water getting converted to steam. So your segments or the calculations will have 4 different segments. E1, why we have chosen different? Because here ice is increasing its temperature from minus 20. So you have to include, or you have to use specific capacity of ice here. In this, there is change in state happening, so you'll be using fusion of latent heat of fusion, you'll be using it here. And E3 water, there is an increase in temperature, so you'll be using specific capacity of water here, the change in temperature is there. E4, you'll be using vaporization. Clear? So you have got 4 different segments. Now, what are the formulae for these sections? Now for E1, since it is just change in temperature, you will be using the formula MC delta theta, right? MC delta theta. Here you have to be careful. You will be using C of ice, not water. That's a common mistake. So I gave you the mass as 5. So 5 multiplied by 2100 multiplied by what's delta theta? Delta theta, you don't have to convert it to Kelvin scale. Even if you convert and take the difference, it will still be 20 degrees. So difference is 20 degrees, and the answer that you get would be 2.1 into 10 to the power of 5 joules. So that's your E1, right? Now E2 will be, here there is change in state, so you are using M into L. Latent heat of, here's fusion, so latent heat of fusion. So this is very simple calculation. 5 multiplied by fusion is 3.4 into 10 to the power of 5, and you get the answer to be, it is 1.7 into 10 to the power of 6, I think. Yeah, 6 joules. So second answer is that. And E3 will be, again, we'll be using MC delta theta because there is change in temperature. But here, which C will you be using? You will be using C of water. So it will be 5 multiplied by 4200 multiplied by, here delta theta is, difference is 100 degrees Celsius, so multiplied by 100. That will give you, E3 is 2.1 into 10 to the power of 3, 5, 6 joules. Right? Now E4 is again M into L, but here it's not fusion, it is latent heat of vaporization. So 5 multiplied by vaporization is this value, so 2.3 into 10 to the power of 6, and you get 11.5 into 10 to the power of 6 joules. So we get it? So if you're using the correct formula and the correct substitution for each of it, the appropriate specific capacity or specific latent heat of fusion or vaporization, so you have to be careful, and the temperature differences also appropriately, so you're getting all this. Now, but the question was what is it, excuse me, total energy required, so you'll have to add all these energies, so you get the total energy. So did you get the different stages and different calculations? Finally, when you add all of them, you will get the answer as, so those of you who skipped the video can check, the final answer is 1.55 into 10 to the power of 7. What would be the unit here? Joules. So it is energy, so you have that in joules. 1.55 into 10 to the power of 7 joules is the answer. Alright. Here again I want to insist on the units. For latent heat of fusion, it is only this much joules of energy is required to convert 1 kg of ice to water. That's how it is. And similarly here it is also, so fusion will only have mass as its respective value. Here C or specific heat capacity will have joules per kilogram, degree Celsius or degree Kelvin. We have seen in the definition it could be 1 degree Celsius or 1 Kelvin, difference is all the same. Alright, I hope you have gotten some understanding. You can practice some more questions from your textbook and get a deeper understanding. See you in another video. Bye.